Okay, great. So I usually like to start off these presentations just with a simple question. Who has used a streaming data product before? Just a show of hands. Wonderful. Who has used Amazon Kinesis, any of the three services before? Wonderful. What brings a smile to my face so much is that every year we give these presentations, and the percentage of the crowd that we see that have used the streaming data product, anything between Apache Kafka, Amazon Kinesis, Spark Streaming, continually goes up, and the number of customers using Amazon Kinesis also continues to grow up. So it's great to see. So for those unfamiliar with streaming data, there's one primary difference between batch data processing and stream data processing. And what I like to think of it is stream data processing is continuous. And you usually do it in real time. So that's what makes up stream data processing. So whereas with batch data processing, you might be collecting logs on your application server, and then you run a cron job once an hour to spin up and send those servers to durable storage like Amazon S3. With stream data processing, you're typically continuously writing data to a streaming service like Amazon Kinesis. So it's one of the primary differences, that the continuous nature versus the periodic nature of batch. The other is the frequency. So when you're doing things continuously, you're typically acting upon a very large volume of small events. So in the example that I just provided, your server wakes up every hour, you're typically grabbing a much larger file, say a megabyte, 10 megabytes, 100 megabytes, or in the gigabytes, to persist that data to Amazon S3. Whereas with Kinesis, you're acting on these typically smaller events. So a 1 KB event that you're continuously writing to a stream, you're aggregating that data, and then writing that data, say, to a persistent store like Amazon S3, perhaps performing continuous processing like computing the average number of API calls for one of your public-facing services. But that's the frequency really is a differentiator between the two. So why do people use streaming data? There's several reasons, but one of the examples that we like to point out as an Amazon Kinesis team is that data loses value over time. And the simplest example of this is, say, fraud detection. So detecting fraud, typically when you have a credit, say you go overseas from your home country, you go to a restaurant, charge your card, and you get an instant notification from many of your banks telling you, hey, we've detected that your recent charge was not typical. That's a real-time alert. And that matters a lot, because if someone did take your card and is using it in some overseas country from your own country, you want that information right away. Being told an hour later, a week later, or a month later, perhaps in a monthly report, that the bank has detected some fraud is not, after many charges have incurred, is not something that is not nearly as valuable as doing so in real time. So a lot of customers move to streaming data so that they can get data into their data warehouses in minutes instead of hours, to react to that data in real time. And Amazon Kinesis provides the mechanism to help do that. So we're going to go through a lot of different use cases in this presentation, but they all follow a very typical pattern. And that is, you've got a data producer, some sort of streaming service, some buffer in the middle that's receiving data from that data producer, and then a data consumer that's consuming data in real time or near real time off of that streaming service. So you'll see this pattern over and over again, but this is when I mention the word continuous, think about a data producer continuously writing to a streaming service. A streaming service continuously ingesting and durably storing that data that's received from the data producer. And then a data consumer reacting to that data, processing that data in real time, and doing something with it. And that something could be as simple as I'm buffering it, running simple ETL, and durably storing it to Amazon S3. And it can get as complicated or as sophisticated as I'm running real-time machine learning algorithms to detect anomalies. So Amazon Kinesis is made up of 3 services: Amazon Kinesis Data Streams, Data Analytics, and Data Firehose. Data Streams was the first service that we launched. We launched it several years ago at AWS reInvent, and it provides sort of the core infrastructure that other services build upon or attach to. You'll build a custom data producer that writes data to the stream continuously. We provide a number of libraries to do so. You can use everything from the AWS SDKs to call put to write data to a stream. And we offer a number of libraries, both open source as well as services like AWS Lambda and Kinesis Data Analytics to consume data off the stream. Follows that same pattern that I described on the last slide. On the far side, Amazon Kinesis Data Firehose was the second service we launched, and we launched it right around 2 years ago. And it takes one of the most common use cases for streaming data and makes it dead simple. And that is, I'm just trying to get a high volume stream of events stored durably to one of my persistent stores like Amazon S3, Amazon Redshift, or Amazon Elasticsearch Service with as little effort as possible. So with Firehose, you create a delivery stream. You set up a number of configurations, and I'll go through some of them later in the deck. And then after that, your data producer just writes to the stream, and we'll deliver that data to you with basically no operations and completely serverless. So a very common use case. Many, many customers use Kinesis data streams in conjunction with Kinesis Data Firehose. So very few customers use one or the other, but we typically see customers using both. Finally, the service we most recently launched was a little less than 2 years ago, Amazon Kinesis Data Analytics. So about a year and a half ago at the New York City Summit last year. Kinesis Data Analytics is a managed stream consumer. So if we think about that pattern that I brought up, on the far end, it continuously reads data from either an Amazon Kinesis data stream or an Amazon Kinesis Data Firehose and processes that data using SQL code. So you set up a streaming source, specify your SQL code to do things like compute the average number of viewers on your website or a leaderboard for your mobile application. And it makes it very, very simple to do that in a managed serverless and elastic application. So let's go through data streams in a little bit more detail. Kinesis data streams, one of the primary value props of it is that you can build a real-time application in the framework of your choice. Again, the pattern that I showed in the first couple slides prior, imagine you're capturing data from either clickstream data from your mobile website or your mobile app, IoT data from your IoT sensors into a Kinesis stream, and then you get to choose one or more of the consumers of your choice. So the four most popular are shown on this slide here. In order of popularity, we provide an open source library called the Kinesis Client Library, which allows you to run custom code on EC2. AWS Lambda, an AWS Lambda function allows you to execute a piece of Python, Java, or a number of other languages code in a serverless framework reading directly off of the stream. Very useful for stateless type of processing. Kinesis Analytics, which I just mentioned, allows you to write SQL over the stream. Very useful for stateful processing, so doing long-running window types of operators. And then Spark Streaming on EMR, which is an open source framework that allows you to do it's a plethora of things, such as simple ETL to machine learning to even more complicated analytics. So Kinesis Data Analytics is the service that I mentioned that allows you to write SQL over streaming data. The primary value prop of this is that it's really, really easy to get started to build fairly powerful real-time applications. So you can set up a POC to read data off of a stream, compute some useful information. We talked about that time to value, the time value of data over time. And it allows you to get that information very, very quickly. So there's two very common scenarios or use cases that we see with data analytics. The first is aggregation in front of a database, and the other is responsive analytics. And we'll go over them later on the deck in a little bit more detail. The aggregation for a database is one of the simplest ones to understand. And it's simple. I either have like an operational database, and it could be a NoSQL database, a MySQL database, a Redis cluster, and I have a stream of events that's coming in at 1,000, 10,000, 100,000, 1,000,000 events per second. And I want to turn that raw stream of events into useful information to feed my live applications. So you'll turn that 100,000 events per second into 10 keyed data per second. It could be the top 10 users. It could be things like what's the last known state per user. And then I'm writing to my operational data store that's feeding my live applications at the rate of 10 per second versus 100,000 per second. The same sort of scenario is done with reporting databases and data warehouses like Amazon Redshift or maybe a MySQL database you're using for reporting, where you're doing a lot of the aggregation up front, so you have far fewer, if any, ETL steps to do before you present your users with a queryable table. So imagine instead of data hitting S3, doing a series of batch ETL jobs, and then finally you get to a queryable table for your users, and that takes maybe an hour, maybe sometimes even more, maybe only doing it once a day, to going to a model where you update that table every 30 seconds or every 10 seconds. So getting that information in there as fast as possible. The other use case is responsive data analytics, and this is really reacting to the data in real time, and it's less to go to a durable store, but possibly detecting sort of a needle in the haystack, finding a particular message of interest, and then sending out several notifications. Maybe you're computing, I mentioned API error rates previously, maybe you're computing error rates, and once they reach a certain threshold, you're sending out a notification or a page. So this is reacting to the data as quickly as possible to feed your live applications. So Kinesis data firehose, I mentioned that when you use Kinesis data firehose, you create a delivery stream. And then after you create that delivery stream, all you really worry about is writing data to the delivery stream. And then the data is delivered without servers, without any operations, to the destination of your choice. So when you configure a firehose, you configure a number of different things. The first and perhaps the most important are what we call buffering hints. And they're both a time period and a size of how large of data or how often do you want to deliver data to your destination. So Amazon S3 being the simplest example, let's just say you would like data delivered in 100 megabyte files every 10 minutes to Amazon S3. And the value prop this provides is that, again, that 100,000 stream of events, 100,000 per second stream of events, you're turning it, instead of ending up with a lot of small files that are hard to deal with on Amazon S3, you deal with very nice, large, chunky files. So it optimizes your batch processing. Amazon Kinesis Data Firehose is really good for if you want to use your existing batch data processing tools. You don't really want to do the real-time processing as much, but you want to make it easier and get that data into those tools faster. Kinesis Data Firehose is a great choice for that. So aside from buffering hints, another things that you can configure are encryption, compression. You can even run inline transformations via AWS Lambda. So sort of like a serverless ETL pipeline, getting data into S3, offloading a bunch of the work, cleaning up that data as it hits your data lake. So back to Kinesis Data Analytics. When you create a Kinesis Data Analytics application, and in general, most streaming applications follow this sort of pattern where you connect to a source, you write a piece of code, in this case it's SQL code, and then you configure where you continuously deliver those SQL results. In the two examples that I provided previously, in the aggregating data before a database, or either an operational or a reporting database, you would deliver those results to, say, a MySQL database, a DynamoDB table, that type of thing. In the responsive data analytics, you would send it to, say, Amazon SNS, maybe even another Kinesis stream, to react to data or to do further processing before you complete your processing on that data. So that's enough about just an overview of the services. The rest of the presentation, I'm basically going to go over some common use cases, and we're going to dive fairly deep into one use case. And then what we'll do is we'll end the presentation. I'll give you guys a link to download a CloudFormation template that works through one of those use cases that I walk through in very good detail. Sets up an end-to-end application that you can run yourself, get a real-time dashboard in a couple minutes. So across all streaming data use cases, let's look at three common scenarios. So streaming, ingest, transform, and load, or streaming ETL. This is very similar to what Kinesis Data Firehose is the primary purpose of it. But people also use Kinesis data streams to do it as well. But the primary purpose is you're doing ETL as data is continuously doing ETL, and then doing that prior to the data, wherever you're storing the data, be it Amazon S3, Amazon Redshift. It's the most common use case we see customers implement, and it's usually where customers start. It probably represents, I'd say, 50% of use cases of what we see for streaming data, just straight streaming ETL. The next is continuous metric generation. It probably represents about 30–40%. And this is getting some insight on the raw stream prior to either delivery or reacting to it. So very common use cases are leaderboards. So I have calculate the number of points per user, do a group rank, and then present that back to the users. Another very common use case is to do computer metric and then do data enrichment on that metric to provide some context, and then pass that event back to users. But the point is that you're continuously doing your metric generation versus doing it in batch previously. And the last one, actionable insights, is really reacting to it. So instead of just immediately storing it and then processing it later or doing something with that data later, you're reacting to it in real time, which is the example I keep on bringing up about sending notifications, pages, that type of thing. So we're going to focus on the bottom two. I'll cover some streaming ETL best practices as well, but for the use cases that I'm going to walk through, we're going to focus on the bottom two. So web analytics and user boards. So here's a common architecture that we see from our customers implement. So they'll have either a lightweight piece of JavaScript client code running on their browser or mobile app, or a web server on Amazon EC2 using Amazon Cognito to provide secure or temporary credentials. And this is what in the pattern that we brought up in the very beginning of the presentation, this is your data producer. This is the data, where you're ingesting the data at the main point and where you're writing data to the Kinesis stream. You'll ingest that data to a Kinesis stream. The most common approach, so when you write data to a Kinesis stream, there's three primary parameters. The stream name, so where you're going to store the events in that temporary buffer that Kinesis Data Streams provides. The piece of data that you're sending, so this could be an individual events or maybe 5 or 10 different events if you're doing micro-batching, writing to that stream. And the last thing is the partition key. The partition key is a key associated with the data that you use to, where we use that piece of data to logically determine where it's stored in the Kinesis data stream. So after ingest, the consumer that we have for this use case is an Amazon Kinesis data analytics application. This is computing the top 10 users. So this will be, when you look at the code for this, it'll be very, very similar to select my key columns, my aggregation columns, group by user, and then there'll be a time period associated with it. So when you're doing continuous processing, one of the primary differences between continuous processing and batch processing is when you do batch processing, you are naturally bounding the data on the data set you're operating on. So you might look at a specific S3 bucket or a set of S3 buckets, and you're done processing when you finish the end of that data. Because of the continuous aspect of streaming data, you need some way to bound your data processing. So computing top 10 users, does that mean for all time, for the last hour, for the last 10 minutes? It's usually a time semantic that will bound the data processing. You can also use different keys, like maybe I've seen n number of events and then I'll stop processing. So give me the top 10 users for the last 1,000 events. You could also say, give me the top 10 users for this specific segment, and do this continuously over time. But the whole point is you need to bound the data processing in some way to determine when you're going to emit results. Where do we send that data? So in this particular case, we're going to use an AWS Lambda function to write it to a DynamoDB table. And this allows us to write data in an optimized format for DynamoDB. Perhaps we'll take a number of results, combine them into a single document, and then upload to DynamoDB. Maybe we'll do some post-processing, like we'll read from past results from the DynamoDB table, combine them in some interesting way, and then upload the results. You'll see AWS Lambda in a lot of these use cases because it really provides some additional flexibility or some customization if you need it in your particular use case. So monitoring IoT devices. So this is another common use case we see. In fact, this use case is growing very, very fast. Kinesis is used by IoT customers primarily because it solves the key problem that I keep on emphasizing, in the fact that you have a large number of events that are generated by hundreds, thousands, millions of sensors. And to ingest that data into your data processing tools and services is very, very expensive if you do by hand. But Kinesis Streams and Kinesis Data Firehouse both solve that problem very well by providing that temporary buffer ahead of your data processing tools. So Amazon Kinesis Data Streams has a number of built-in integrations with data services across AWS. They include AWS CloudTrail, VPC Flow Logs, CloudWatch Logs. The one I highlight here is AWS IoT Service. When you set this up, you can configure a very simple rule in the AWS IoT Service to forward data to a Kinesis stream. And you can forward all data or a filtered set of data. You can forward to n different number of Kinesis streams. Here I'm just forwarding to one. This is a very common use case for both AWS IoT as well as Amazon Kinesis, because the integration is it's serverless. It's very easy to set up. It's very easy to debug when there are issues. So getting that data again into that stream, and here we're computing the average temp every 10 seconds. So I've added the time parameter in which we're computing it. So, and then triggering, if a temperature reaches a certain point, you're triggering a Lambda function to perhaps react to the data or persist that data into a time series analytics into a database. So again, you see very common patterns around these common use cases because it's what we see customers typically do. So this is the use case we're going to be spending the majority of the time for the remainder of the presentation on. I mentioned that the Kinesis data streams as well as Kinesis data fires have a number of built-in integrations with other AWS services. CloudTrail is one of them. So with AWS CloudTrail, you can set up an Amazon CloudWatch event trigger, and this is basically a simple trigger to take data that's generated by AWS CloudTrail and send it to Amazon Kinesis. AWS CloudTrail, for those who are not familiar with it, it logs activity associated with your AWS account. So the API calls that you make, when you work with the SDKs, when you work with the console, that gets logged, as well as metadata about the call gets logged. So the IAM users making the call get logged, whether the result of the request get called, a lot of very useful information. So people typically analyze these to perform things like audit checks, compliance checks, to track usage, and even for operational use cases. So you want to know if one of your users spun up n number of EC2 instances or something like that. AWS CloudTrail provides a very useful mechanism to track that information. The combination of AWS Kinesis services I show here provide a useful metric to develop very valuable operational metrics. So things like, what are my top 10 IAM users for any given period of time? What user is calling EC2 the most often? Are there any anomalies associated with how my users are calling EC2? These are all metrics that can be computed in Kinesis Data Analytics, and we'll walk through some of them later today. Again, very, very common scenario that I show on the back end of this is using a combination of Kinesis services and AWS Lambda to persist data to a durable storage like Amazon DynamoDB. And then archiving the raw events throughout the pipeline. So Kinesis Data Fire stores the raw events if you want to perform batch analysis later, as well as has a bucket for process data. So you can reevaluate any past results as well. So I'm going to go through the use case I just went through sort of in pieces, right? So I'm going to go back real quick. So we're going to go from left to right, like this is the ingestion. Here are some common scenarios associated with this use case as well as the broader use cases. And then the middle part, the actual processing, we'll walk through how to do windowed analytics using Kinesis Data Analytics. And then the final part will show some best practices associated with persisting data to Dynamo. So as I mentioned, CloudTrail provides a basically continuous logging of account activity. What a CloudWatch Events does, and it does this is not the only integration that CloudWatch Events does, but it allows you to trigger an event from point A to point B. So as an example, we're sending data to Kinesis Data Firehouse here, but you could also send it to a Kinesis stream. You could invoke a Lambda function. You could send it to CloudWatch logs. It's a very useful integration that not a lot of customers, I feel, not enough customers know about, because it's basically set it and forget it. So you set up the CloudWatch event trigger and the data starts just showing up into the service that you pick. And there's a lot of different combinations between point A and point B outside of even streaming data. I highly encourage you to look at it. So each event, I said, it includes a bunch of useful information. And one of the things it includes is a timestamp. And we're going to go a little bit more detail with this later, but what's important to note is this is the timestamp that the event was created. So when the call was received by the AWS service, the metadata associated with that call is sent to CloudTrail, and then through CloudWatch Events sent to a Kinesis data firehose. We typically call this the event time or the client-side time. And it's when you're computing metrics in real time, the concept of time is very, very important. In this case, this is the event time. Kinesis data firehose, in this case, archives all data in Amazon S3 using the buffering hints that you have. Since this use case is a real-time processing use case, the files that will probably deliver to Amazon S3 aren't really latency sensitive. We're doing much faster processing in another part of the pipeline. So we might set our buffering hints for this to be maybe 1 hour or very, very large files so that we can more efficiently work through them. If you didn't have the other half of the pipeline, you might set the buffering hint to be a lot faster, so maybe once a minute. So you get that data to land in S3 and start your ETL processes as fast as possible. So I mentioned there's a lot of different ways to get data into Amazon Kinesis. And when Amazon Kinesis here means Amazon Kinesis data streams and Amazon Kinesis data firehose. So there's several services that we have that are enabled for automatic ingestion, including VPC flow logs, CloudTrail, CloudWatch logs, AWS IoT, and Amazon Pinpoint. And when I say automatic ingestion, I mean you go to the UI or download the CLI and you make 1 or 2 API calls and it's set up. And data is just automatically writing to the firehose or the stream. So I wouldn't even call it easy. It's like dead simple setup. The next is sort of easy setup, some very common patterns that we see. So since Amazon API Gateway has come out, a very common pattern that we have seen is just using API Gateway to forward data to a Kinesis stream. ELB is also used in this scenario, and sometimes they're backed by Lambda functions or EC2 instances, sometimes they're not, but meaning that you'll have API Gateway, which will send data to a Lambda function, which in turn will send it to a Kinesis stream. Some customers skip the Lambda function, some do not. The other for the easy setup that's a relatively common use case is change data capture. So example on Amazon RDS, you can set up an agent to read from the bin log associated with that and send change data capture events directly to a Kinesis stream. We have an agent, which is on the right-hand side, called the Amazon Kinesis agent, which just tails a log file and does things like file rotation, things like that, that durably sends data to a Kinesis firehose or Kinesis stream very, very easily. Setting up those for RDS, very quick to set up. So we're talking minutes or hours to set up. Or you can write your own. We offer a number of open source libraries. The one I just mentioned, Amazon Kinesis Agent, really optimized for like the log ingestion use case. We also have Log4j, FluentD connectors that allow you to write data to a Kinesis data stream. We have an Amazon Kinesis producer library. This library is specifically meant for large log servers. So if you're generating, tens of megabytes of data per second, it's very, very efficient in writing data to a Kinesis stream. It'll buffer and batch the records per configuration. It'll compress them. It will use protobuf if configured. So it's all about it's really about cost optimizations and throughput optimizations. And finally, and I would be remiss for not saying this, the AWS SDKs, which are very, very, very easy to write with probably 10, 15 lines of code, write a data producer using an AWS SDK. On the Amazon Kinesis Data Streams website, there's a developer resources page that provides a little bit more of a comprehensive list than I have here. It has a bunch of links to GitHub where we have some of these open source libraries. So have a look. This is just a sample of some of the more popular ones. There's a lot more. So we're now on the middle part. Right? We ingest the data into a Kinesis stream. Now we're going to compute some operational metrics on that real-time data. So if you remember, the CloudTrail log includes the call, the service that you called, the IAM user that called it, the actual API that you called, the timestamp associated with it. This is very useful information about what you're doing within your AWS account. There's a lot of different patterns for how to analyze this data. The pattern that we're going to talk about today is how to process it using Kinesis data analytics using SQL code. Some of the metrics that are useful are things like the EC2 API failures. So are you continuously making an IAM error when you make an EC2 call? Detecting that type of thing. A percentage error rate on a specific API call from a specific IAM user. So like maybe you have a cron job that starts up every 5 minutes, and you really want to make sure as fast as possible that cron job was successfully run. And when you know the API signatures associated with that call. This is one mechanism to do it. The purpose here of me bringing up these examples is that you really can get fairly specific with the customization of what metrics you compute, and you can do this in real time. So how do I write streaming SQL code? What does it look like? So there's two primary concepts when you build a Kinesis data analytics application. So there's three primary components: the source, the code, and the destination. We will continuously read data from the source, continuously process that data with your code, and continuously emit the results to the destination that you've configured. The code for the middle part, there's two primary components of the code. There are these in-memory objects that we have. They're called in-application streams. You can think of them as almost like a materialized view on the stream. Right? So we ingest your JSON data. We'll auto-detect most scenarios for JSON data. We have some mechanisms to work around those issues if we don't auto-detect it. And then we map them to a stream with the column types and their data value types. So like the event timestamp, computation type, varchar 256. This is similar to a table. You create this in your application code, nothing happens. It's just an object, right? In order to get it to actually process data, we have this second concept called a pump, which is basically just this continuous select statement that we're inserting into the stream. The source stream that we create, that is the materialized view on your Kinesis data stream, your external Kinesis data stream, or your external Kinesis data firehose, is always represented by source SQL stream 001, something like that. In higher scale use cases, we will enumerate it, so it'll be 001, 002, so on and so forth. For most customers, it just looks like this. So you're going to select from one stream and insert into another stream. This allows you to develop basically serial step pipelines in your application code. So one of the most common scenarios we see is the first step, dedupe. So deduplication over a window, get rid of any data duplicates that might have been caused from the data producer based off of a set of keys, or maybe you only want one event per user coming in, something like that. But deduplicating the event, or perhaps a filter. The next step is usually the analytics step. So you'll do one, insert into a stream, read from that stream, and then perform your analytics. So here I'm selecting the event timestamp, which is an important concept that I brought up. This is the timestamp when the event was actually created. That timestamp that I brought up earlier in the presentation. You make the API call to the service, it gets a timestamp. We're calling that the event timestamp, approximately when the event was created. You could use your own timestamp associated with the API call as well. The next concept is the processing timestamp. And the processing timestamp is the server time of the application. So it's one of the only concepts we expose from the server is the clock on the server. And it basically is whatever nodes are running your application code, it's the clock time of those nodes. In the group by, we've got a couple things here. The group by a key, so in this case, the source IP address, and then two step functions. The first aggregates data by the processing time, and this serves as basically a trigger. It says, we want results emitted every minute, continuously. The second step function is essentially a key-based grouping. So I want them emitted every minute based off of the clock time of the application node that's processing data. But I want to group them by their event time. Why do we do this? I'll go into a little bit more detail, but we do this to handle late data. When you're processing data in the batch context, all right, your data has those bounds, right? You do one job, it runs up, processes all the data. That's the context of what the data processing was. Whatever, it's confined by just the data that you specified in your job. With streaming data, we're running this continuously, and we're typically computing at a much higher frequency. So in this case, it's 1 minute. So over the course of that minute, you might have events that arrive on time, meaning that milliseconds or seconds after the data was generated by CloudTrail, it's processed by your Kinesis data analytics application. So we call that on time, when the difference between the application node or the process time is very little between the event timestamp. But you also will have guaranteed to happen late events. And these are events that arrive late due to servers crashing, network lag. It could be a number of different things. Maybe you had a process restart on one of your EC2 servers, and then it arrives a minute or two late. So how do you deal with that data? This is the mechanism Kinesis Data Analytics deals with it. We'll emit that data, but we'll handle the late data by aggregating it by its own key. For some use cases, this is very, very relevant. So if you want to use accurate results and use them for a long period of time after the fact, this is the mechanism you want to use. You want to group by your event timestamp. For super real-time use cases, we have customers just filter out real-time data. And a super easy example of that is you're detecting number of live sessions a user has. And you say that the user may only have 5 sessions at once at any given time. And if they go above 5 sessions, then you're going to block any other sessions. So like, imagine you're logging into Netflix and you're detecting the number of live sessions they have. They only allow you to have 5. If you have 6, they block you out. In the context of this, late data means nothing. So the people just discard it. So this concept of time is extremely important. We'll go through it in a little bit more detail as we go through the presentation. But think about your use case and whether this data is going to be useful after the fact. If it is, you want to group by your event timestamp. If it isn't, perhaps you just want to filter and throw away all the late data. These step functions that I talk about are called windows. And when you do a sum, a count, a min, or a max, these are called windowed operators. And there's different types of windows. What I just showed you is a tumbling window, but there's also sliding windows, session windows, hopping windows, lots of other different custom windows. There's lots of different types of windows. And the windows define the bounds. I brought that up several times now about you bounding a result set by time or by key. They define where to start your computation and where to end your computation on a continuous data stream. So again, we're in the batch context, you're just bound by the data you're doing the job on. In the streaming context, you've got to specify the bounds when you do things like aggregations. So when do I want to stop aggregating results? And Windows provide that mechanism. So I mentioned there are several different window types. The example we have up here is a tumbling window. What makes a tumbling window unique is that it's a fixed size and grouped keys do not overlap. So meaning that from left to right, the results, if I'm just doing a count, would be, if I can read it correctly, 2, 4, 3. They're non-overlapping. They're the same size. The size in this case is defined by time. So t is equal to 0 to 5, 5 to 10, 10 to 15. So sliding windows and session windows and other types of windows have different mechanisms. Some of them might be fixed size. Some of them might not be fixed size. Some of them might be overlapping. Some of them might be overlapping. So an example of a sliding window is overlapping. All right? So a sliding window computes a rolling window. So instead of the time being from T0 to T5, you'll see that window continuously compute. So at any given point, it'll say, doing a count again, 1, 2, and then we might include the third event in that sliding window, 3, so on and so forth. And as events enter the window and exit the window, the result changes. Tumbling windows are great for reporting and leaderboards and things like that. Sliding windows are very, very good for operational analytic use cases. The reason being, sliding window, you get a result whenever the result changes, essentially. Tumbling windows, you get a result at the end of the window. So you have that group by that I showed on the last slide. We'll get that count of 2 at t is equal to 5. all right? Versus a sliding window, you'll get a count of 1 at t is equal to 1, 2 at t is equal to 2, and then if your window is longer, 3 is equal to t is equal to 6. So you get the result immediately. This is why it's great for operational use cases. A lot of times they're used in conjunction with sliding and tumbling windows. The other windows get a little bit more complex. Another example of a window is a session window. A session window is overlapping and not fixed size. And you can think of it as a user session on a website. So a user logs onto your website. They might be browsing for 2 minutes or 5 minutes or 10 minutes. You don't really know ahead of time. You're closing the window based off of some condition associated with it, such as, I haven't seen any events from this particular user for 1 minute. I'm going to assume the session is closed, and now stop my aggregation, emit the result. So there's different types of windows, but the two primary components you want to think about is what size are they? Are they fixed or not fixed? And whether they overlap or not. So event, ingest, and processing time. And I covered this a little bit on the earlier slide. And this is a copy-paste from the previous SQL code. So in this particular case, we're triggering the results by processing time. That clock, we monitor those on the applications. And if you use any other streaming system, they do the same thing. We're monitoring it and making sure that the clock is accurate. But every minute, you're going to get a result, no matter what. The aggregation key is on the event timestamp is really the timestamp grouping key. This is what the result is you're going to have. The result you're going to have that means something to you. It doesn't matter what the server time is to you. The event timestamp is what you want to do your aggregation on for use cases that require it. So what happens with late data? So some late data is very easy to handle. Perhaps you have got 10 events, 9 arrive on time, 1 arrives late. And you've got a keys associated with that. What we'll do with this code that's in front of you is when the minute is over, we'll omit that 9, and say that event comes very late. Let's say it comes an hour late. We'll then event a 1. And you'll post-process the data to combine them to 9 plus 1 is equal to 10. This is why databases are so popular as a destination for streaming analytics, because they provide a very easy mechanism to do things like insert on duplicate key. So I'm inserting for this set of keys, for this timestamp. If I already have a value, add them together, or define the max. So we went through the middle piece, and we went through the ingest piece. The last piece is persisting data, and for this case, it's for a real-time dashboard. So walking you through the architecture that we chose for this particular solution, we're taking the real-time metrics that we produced off the CloudTrail data, like top 10 IAM users, EC2 failure rates, so on and so forth. We're writing them to a Kinesis data firehose, which archives all the data in Amazon S3. So if you need any of the process result, we're doing long-term archival in S3. We're then going to use the Lambda function to update the DynamoDB table. And it's going to have some of that logic that I mentioned about previously, that insert on duplicate key logic, to combine late and current results with previously computed results. In this solution, we also have a real-time dashboard, which is, in the example I'm going to provide at the end of the slide, what we use is just a popular open source library for drawing graphs called chart.js. And it's a very simple way to get real-time dashboards via a static website on Amazon S3. Another common use case is to write this data to Elasticsearch. A lot of our customers, Amazon Kinesis all up across all 3 services. A lot of them use Elasticsearch and Kibana for visualization, so they might send the data there. You might send the data to Amazon S3 and visualize with QuickSight. We use this solution because it's very, very simple, and very easy to set up, very easy to customize, and it's very cheap. So with that, so the late events, I mentioned writing data to a database has advantages in that when we produce these amendments, you can combine the two. In certain cases, this is easy to do. So in the count example, it's dead simple. Min, max, very, very easy to do. So what do you do, though, if you're doing like a count unique? Or if you're doing the result of machine learning algorithm or something like that? The difference between the metrics that I just talked about and the two examples that I just brought up is that, one, the results are cumulative. And it's super easy to get a real-time result and then update the results for late data. The other two, you need to do recompute. You need all of the data in the time series to recompute it. So if you're doing a count unique, you produce 100, a late event comes in, the count unique will be 1. So what we typically recommend for use cases for those scenarios is to produce either longer windows and produce multiple results. So you'll have one set of windows that produce the results immediately, and another set of windows that compute it over longer window, maybe an hour, to make sure that all the late data has arrived. So you get both an early result and a complete result. This allows you to do all the processing in the real-time application without another thread to do cleanup after the fact. Again, this would be handled by the Lambda function in post-processing. When you insert on duplicate key, you mark whether it's a complete result or not a complete result, and you update the row accordingly. So what does all this cost? So the solution that using data available to us, the average CloudTrail customer, average number of API calls, the solution I presented to you today with all the details is about $100 a month. So it's about $60 a month in Kinesis analytics costs, and the remaining of the services are about $40. And you get a live dashboard that feeds you real-time results. So where do you go next? So if you go to this tinyurl.com/real-time dashboard, I have basically this 3-page document, very simple solution that shows you how to fire up a CloudFormation template. And for those of you taking pictures, we post these slides as well after the fact, so you won't be lost with it. You basically can set up with a couple of clicks. You'll get a live dashboard on your AWS account activity. And we chose some very, very common things that we've seen other people do, but you can customize it to meet your needs, which is part of what I brought up previously, the fact that part of the power in the solution is, first, it handles a lot of scale. It's very easily customizable. You can write your own SQL code, modify it to make your own metrics, add your own graphs, and it's cheap. It's very inexpensive, and you get a lot of value from it with a very, very little setup. The other thing I'd encourage you guys to do is go out to one of the blogs my favorite blog on the AWS is the AWS Big Data blog. We have a lot of great customer examples, not just for this example, but a lot of other solutions. We'll have some Spark streaming examples, some AWS Lambda examples that follow similar use cases to this and other use cases. On the Amazon Kinesis website, there are a lot of customer examples that provide good references to how people have solved these problems before. There's a lot of customer diversity here. We have enterprises, advertising technology companies, mobile apps, online retail. So you should be able to find an example either in the blog post or on one of our customer references that helps cater to sort of what you guys need to do. Since I just went through one use case, there are many, many different use cases that customers solve for, and these will help you provide a starting point. We also have a lot of integrations. So we showed one example, but we have a lot of customers that use one of our other solutions. So they might not use Kinesis Data Analytics, they might use Splunk. Kinesis Data Firehose actually recently announced a beta for a Splunk integration. So if you just want to deliver your streaming data to your Splunk cluster, we've got that. We have a number of connectors with other solutions, such as Databricks, Apache Flink. This is one way to solve a problem. So there's many, many different ways to solve the problem, and they all provide very, very good integrations. If you need some help, we've got some partner systems integrators that have a lot of experience helping customers along, building their first or their second or third streaming data solution. So with that, thank you guys very much for attending the call, attending the presentation.